All right, so I want to chat about hydraulics. Now, those of you in the class last year heard some of this, but I'm going to run over that again just to make sure we're all clear on this. And then, like stupid fly. Anyway, and then we're going to move into some newer stuff, and then we will be working on hydraulic cylinders, putting those four back together. We'll be doing a few other hydraulic issues this year. I have a good buddy of mine that wants us to do a couple for him as well, so we're going to get comfortable with it. Now, again, hydraulics works like this. Okay, we are going to have, whoop, in the case of a hydraulic cylinder, looks like so. Obviously attached on one end down here. There's a ram that comes out of it like so. Hooks onto something up here and pushes on it. That ram comes inside of here and then hooks to a piston. Okay? You're like, oh, dude, I know how pistons work. Of course you do. So the game is thus. We're either going to pump oil into here, and we're going to put pressure in here, right? Which forces the piston down. To do that, you need to be able to get rid of the oil that's down here, yes? But what if I want to go the other way, Groom? Well, then I change directions, yo. And I start evacuating fluid from here. Bloop, 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 bloop. And I start putting fluid into here, which then, of course, acts upward. Ta-da! And you're like, well, how does that change exactly? That's a great question. So, we are going to talk about that in a few minutes. But remember, the principle of hydraulics is this. One of the biggest principles is this. Fluids cannot be compressed. Only air can, or only gases can be compressed. Okay, so this is why when we do brakes, we have to bleed the system to get the air out, because otherwise, when you push down the pedal, you compress the air, and then you're like, that pedal feels spongy because it feels like you're stepping on a balloon. Okay, because you're squishing the air. But if you step on it and there's no air in the system at all, when you push in on the brake pedal, you actually push fluid out, and it does work outside in the car. That's actually a hydraulic system. So we're going to go through several of these systems as we go along. Okay? So the game is this. There's a couple things. First of all, how do we get fluid in? How do we get it out? Okay? So some questions here. So how is this fluid going to be getting in here? Via hose, obviously. Thank you. But where is that hose coming from? Where is it? How is that get done? Okay, so in the case of a jack, in the case of a hydraulic jack, it goes like this. You've got this big, boop, 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 this big piston here of a thing. Okay, and it's a big piston acting on this, and it is getting pushed up, and then you lift your car up. Okay, yay! Where is the fluid coming from? Well, the fluid is coming in like so, and where is it coming from? Well, over here, there's a little tiny piston, and it is attached to this guy. And there's a little tiny piston right there. And you are over here at this handle, and you're pushing down the handle. You're forcing this piston down. You can't compress this fluid, so it has to go somewhere. But Groom, how much force, how much pressure am I putting on it? I don't know right now. But I'm putting some pressure down. It has to go somewhere. And the only place it can go is over here. But if it comes into here, what does that mean? It means this fella has to come up. Okay. And so what happens is this, is we move the same amount of volume of fluid. All right. So when you push this down, let's say this has a 1-inch radius, which is huge, but it's going to make my math a little easier. And this has a 4-inch radius over here. Okay, well, if you do the math on that, if this goes down, let's say we're going to pump it down 2 inches, then the volume is equal to pi times the radius squared times the height. So if you're doing the math on that, you're going to get pi. I'm just going to leave it in terms of pi. It's going to be 2 times 1 squared, which is 1, times 2, times pi, it's just 2 pi. That's cubic inches, or yeah, it'll be cubic inches in this case, of fluid gets pushed out. Well, the same amount of fluid has to come into here. But the volume over here is pi times the radius squared times h. So it's going to be pi, okay, times the radius squared, which is 16, times h. And of course, remember that has to equal 2 pi, right? Because That's how much fluid came in. This is the volume of fluid that we moved. And so the pi's cancel out, and you get h equals, it's going to go up 1/8 of an inch. So for every 2 inches of stroke on the little guy, you're going to go up 1/8 of an inch over here. Well, that's interesting, because how much force did I apply on that little guy? It's a great question. So remember, and if you don't remember this, I'm going to tell it to you now. Pressure is force over area. And I always say this every year because I love to remember Mr. Patterson. If you never met Mr. Patterson, what a great guy. I think he retired 4 years ago now. But when he first came here, same year I came here. Well, no, he came the year after me. And I didn't know him very well at that point. He called me at 10 o'clock at night, wanted to know if I had a pair of size 10 men's pumps. I mean, you mean like high heels? He's like, yeah. I go, no, you freaking creeper. And yeah. So then the next day I get to school and he starts asking, and I said, what the heck are you talking about, weirdo? And he did a thing, it's a pretty cool math thing about, hey, if I was wearing this pair of high heels, the pressure on this guy right here is immense versus walking on a snowshoe or something, right? That's the whole idea, because there's more area, less pressure, okay? And so on the little fella over here, the pressure that I exposed, let's say I put 100 pounds of force pushing downwards over the area of this guy. Well, the area is pi times the radius squared, so it's just going to be 1 squared, which is 1, so just 100 divided by pi. Or in other words, about 33 pounds per square inch. Yes? Excuse me, that's how much pressure I was generating by pushing down on that guy right there. Okay? And you're like, huh, okay, well, what does that do for me over here? Well, that's a good question, because that means I now have 33 PSI everywhere in here. Everywhere. So, but what does that do? Well, it's lifting the car. It's applying a force to the car. And so pressure is equal to force over area. So 33 PSI would be equal to force divided by the area. Now, the area here is 16 pi square inches. So if you're doing the math at home, that's 33 times 16 pi. You're getting dadgummit. Dadgummit, give it to me. You're getting about 1,658 pounds of force that you're getting out of this thing. Wait, that's a lot more than I had before. Yeah, it's approximately, I don't know if you do the math on that, we were putting over here 100 pounds of force on the thing downwards, right? And we're getting 1,600 pounds out, roughly. That's a little off because I rounded my pies. It should be exactly 16-1. But that's pretty impressive because of what we're doing with this thing, okay? And that's mechanical advantage, but that is hydraulics. That is how it works. The question then is, well, when I get on the excavator groom and I open the valve and I let things go, I'm not physically pumping the valve. I'm not creating the pressure. And you're right, exactly. So on pretty much every hydraulic system that we're going to have, we have an engine here, obviously. And somewhere off the crankshaft, whether it's directly off the crank or whether it's off a pulley up here somewhere, we have a hydraulic pump. Hydraulic pump. Okay? And when it's run right off the engine, that means if the engine's running, the pump is running. We refer to these as live hydraulics. So as soon as you start the engine running, you have the ability to have hydraulics. Groom, is it true that the skid steers have live hydraulics? Yes, and no, right? Well, so they have a safety feature built into them, in that they have a hydraulic, they have an electronic valve that does not allow you to use the hydraulics until you push a button, right? And the flippers down over you to hold you in place. But when those two things are in place, hey, the engine's running, you got hydraulics, okay? And so live hydraulics are pretty amazing things. That means as you're just sitting there idling, the engine doing its thing, you can then run the hydraulics because the pump is already running. Now, when I was a kid, some of the tractors we had as kids, we didn't have live hydraulics. That is, it ran off the PTO. So the engine turned the transmission, The transmission, if you put the PTO in gear, would spin a shaft, and then that would go. So if you did not have the PTO engaged, you didn't have it in gear, then you didn't get hydraulics. Those are not live hydraulics. We're going to talk about live hydraulics primarily in this class, okay? Because that's pretty much the industry standard, okay? You are going to have a reservoir. You mean the tank? That's just what I said, correct. The reservoir, okay? It's got fluid in here, okay? We are going to have a big suction line over the pump. Okay, there it comes. Now, why do I need it to be a big line? Because I need to be able to suck a lot of it in. What does the pump do? The pump creates pressure. Well, how does it create pressure? And we talked about this last year, and so this is high pressure. You're like, Groom, this is the suction side. Is it technically a vacuum? No, it's low pressure. You could think of it kind of like that, but no, it's not. Okay, it's high pressure, low pressure. And this is huge, people, okay, without restriction, there is no pressure. So we're going to look into a little bit about some pumps a little bit later on. We'll talk about a couple different kinds of pumps. But in either case, what's happening is you're bringing in a lot of fluid, and you're forcing it through a very tiny opening. That's how you're creating the pressure. Okay? So it's coming out the other side on the high pressure side. Now, this guy right here, I'm going to have him coming back here somewhere. Again, these are live hydraulics. Nice. And then you're going to come back to, and this is, again, I'm drawing up a very typical design to move. Well, I'm going to start off with just a hydraulic ram. Okay? It's going to come back to a valve. Okay? It's going to come back to a valve. And that valve is such that if you're not using the valve, this stuff just cycles back around to the tank. Boop. And away we go. Okay? Again and again and again and again and again. Okay? That said, the valve then is also going to be hooked to our hydraulic ram. Like so. One hose coming in the bottom of the ram, like so. Oopsie daisy. And one hose coming out into the top of the ram, like so. Okay. So when you move a valve, there's a valve in here, what's going to happen is this. When you move it one direction, let's say I move it this way, what ends up happening is you connect these guys like so, and so the path flows from the pump through into the cylinder. And remember, there's a piston in here, yes? So as it fills this bottom half, yes, the piston goes up, and this is brought back. Now here's the best part, and it goes back to the tank like that. So when you move the lever one way, it flows like so, and then back to the tank. If you move the lever the other direction, oh, dadgummit. I suck at drawing. All right, let's try that again. So if you move it the other direction, just a minute. I'm going to redraw the return line. There's your return line. Back to the tank. Okay, so then, boop, down to the bottom, up to like so, off of here, into here, off of here, into here. Now, if I move the valve the other direction, boop, boop, what happens is that then the fluid comes this direction into the top. The piston then goes down. This comes back up into here and then is rerouted back to the tank. That is called a valve. That's just a nice bidirectional valve. Okay, I can have it go one way or I can have it go the other way. So I will show you a couple pictures of them, but the general consensus is it looks like this. Viewed from the top, you typically have flow in, like from pump. You have out to tank, and then coming off the top, you typically have to cylinder, and then to cylinder. And so what ends up happening is, here's your hydraulic cylinder again. Here's your piston between the two of them again. Boop, boop. Like so. And so when this valve is in one direction, let's say it's pushed up this way, you're going to get flow that goes like so, and then like so. Well, I'm sorry. It comes in from the pump, comes under here. The top comes back out and goes to the tank. Okay. Now, if you flow it the other direction, if you move your handle the other way, what then you get is this. It's coming in, but it goes to the top of the cylinder. The cylinder comes down, it comes out the bottom and goes back to the tank. Okay, so that's if the valve's in the other direction, like so. Okay. Now the question is, what is this thing here called? Well, this is called a spool. This is referred to as a spool valve. Spool valve. There's not an E on spool, stupid. A spool valve. Okay. And that spool is such that when I move the lever, because I can have one that's a lever. If you saw it in the shop the other day, there is actually a spool valve sitting on the back table in the shop by our hydraulic valves. It came off of that other old tractor. When you move it this way, it pulls the spool back out and it sends it one direction. If you move it this way, it pushes the spool in, changes direction. We are doing a lot more of solenoid valves anymore. And so for some of you, you don't remember what solenoids are, so I'm going to hit you again. Remember, you have a coil of wire. Yes? Whee! And if you run current through a coil of wire, current through a coil of wire creates a magnetic field. And you can actually change the direction of the magnetic field by changing the way the current flows. So let's say I do it this direction through there. It's such that it would pull the spool, let's say, this direction and open it up this way. And if I want to go the other way, I just send the current through this current. I send the current the other direction, and it would create a magnetic field that pushes the spool away from me. It's that easy. Groom, what brings it back? Well, if you let go of it, a spring will bring it back every time. Are you with me? A spring will bring it back every time. By the way, the hydraulic system on the Chevy dump truck out there for heavy equipment, and the one on the dump trailer, okay, those are run by not the engine of the truck and not by the engine of the, like the pickup when I'm pulling it with the trailer. They have a little electric motor that spins the pump. But those are a little bit different in that instead of putting fluid on both sides of the piston, on those situations, on the dump truck and on that dump trailer, you are only pushing fluid in the bottom. That jacks the trailer up, so eventually it's going to look like this. It pushes it to the top, and that's hooked to your bed, so your bed's tilted now, yes? But when you shut this off, what ends up happening is it allows it to bleed back, and so gravity forces it back down, okay? That's a single acting cylinder. They do show up. They show up on dump trailers. They show up on things like that. But most cylinders that you will see are actually going to be double acting cylinders. That is, they can go in either direction. Okay. Single acting cylinders are they're not the greatest. Okay. Like for instance, when they first put those on like little wheel tractors back in the day, like I want to go scoop some manure or something on the farm. You can't push down on it. Okay. You can only let gravity take it down to the ground. So as you can imagine, you can't dig very good with them. So with the Bobcat or the Takaguchi skid steer, if I had only single acting cylinders, I could slam it on the ground. That's all I can do. But in fact, I can push down with those. I can lift the whole front end of the tractor off the ground, right? That's how I can dig with those guys so well, is because of that. I have to have double acting cylinders. But back to this, a solenoid valve. So solenoid valves, it's the exact same thing. You're just moving the spool. So the spool, I'll get you a picture of one here in a minute. Yes, here we go. Let's do this. Hydraulic spool valve. Oh, for the love of Pete. That's not going to work. Hydraulic spool valve. There we go. Cool. How exciting. So those are what the valves look like. let's see a picture of the actual spool. All right, so let's just get to the hydraulic spool. Let's do that. Doop. Doop. Oh, yes. That thing right there, my man, is a spool. Okay, you see the cutouts. When you move it one direction, this guy here will connect two different ports. This guy will connect two different ports, yes? And when you move the other direction, these two will connect. Okay, that's the idea of it. That's the same thing you see kind of pictured in some of these these renderings, like right here. See that? So right now, if you move it, it's going to block off one port. It's going to open up other passages with that spool. Okay. Obviously, there's going to be a spring that snaps back in there. That's just obviously going to happen. By the way, later this year, we will be looking at some hydraulics in some transmissions. In a transmission, an automatic transmission, you also have spool valves. They move one way or the other way to let flow go to do our thing. So that's what they'll be looking at. Really, again, not a big deal. This one right here, this guy on the outside edge right here, this piece right here is referring to the solenoid. And so instead of a lever moving the spool, a solenoid moves the spool. That's it. Now, as you know, if you've used the heavy equipment at all, we call that electric over. So solenoid valves or electric over hydraulic is another way of thinking about it. When they first came out, they were a little sketch because you could not control how fast it opened. With a handle, I can crack it open just ever so slightly and get them oil to move not as fast so my bucket doesn't shoot up to the top of the ceiling or drop on the ground. Okay. That was harder to do back in the day. I remember my grandpa had this combine back in the 80s. We had this style. That's the steering wheel, by the way, in case you're wondering. Yeah, that's a good looking steering wheel. It had these two big levers. One to control speed and one to control header height. If I wanted to lift the header up, I pulled it back, and that physically moved the spool. If I pushed it this way, I lowered it down. Okay, and it was pretty easy, I thought. The first time I ever got in my grandpa's combine, which was a few years newer and in a different model, okay, this joystick determined how fast you went forward, and there was a little rocker switch right here that raised your header up and down. And if you wanted to go in, you push up, you push the top. If you want to go down, you push the bottom. First time I ever touched that with my thumb, okay, I was going along and I wanted to just bump the header up like a half an inch or an inch or something. And it like, it's clear up to the sky. I'm like, good night. I had to back up, put it back to the ground. I'm going along. I bumped it down a little bit. Now I'm cutting. I'm just in the dirt. I'm like, this is ridiculous. So when these first came out, they're a little problem. But as you know, if you've been using the heavy equipment stuff, we can pretty much reach out and scratch your butt with without, it's like, from a distance with the excavator, right? Pretty easy now because we have better touch on our joystick controllers now, right? So instead of just all of a sudden the spool's wide open, we got full flow. We got just a little bit of flow going along those lines, okay? Now, a couple other things I want to chat about this. Oops, shut up, stupid. About this aspect before I move on from it is when we start looking at hydraulic cylinders, a couple of things come to mind. So I'm going to draw a little bit better picture here. So here's my hydraulic cylinder. I'm going to draw it sideways. And we're going to label some pieces here in a few minutes. Okay. This is the piston. I already mentioned that. There's our piston. This is the hydraulic. This is what you call it, the rod. A couple other names for it. We'll talk more about that later on. Okay. So again, there's your piston right there. So a couple of things come to mind. If I'm putting pressure or oil into here, and of course it's coming out up here somewhere, whatever, okay? A couple of things come to mind. First of all, you need to have this sealed tightly around the ram, right, around the actual rod. Does that make sense? It has to be tightly sealed around there. And so when we look at this piece here is actually referred to as the gland. And so, of course, it's going to have seals. Groom, is it screw in? Yes, this thing screws in to the top of the cylinder. It screws in. Well, are our threads are they gonna hold oil? And the answer is no. So there's going to be seals, typically O-rings, on the outside of the gland. Okay, we got to keep the oil in. But if you build enough pressure, it should shoot past it. We cannot have that happen. But likewise, there's seals on the inside as well. Okay? So some of those seals are O-rings, and some of them are just plain different kinds of seals. Okay? Now, right around the edge here, right at the top of it, there is a seal that's called a wiper. And what that does is this. I get a bunch of dirt and crap all over this rod, some moisture. I don't want that inside my cylinder. So it literally, its job is to wipe the rod as it goes in. You're like, Groom, is that? Yeah, you can think of it that way too. Sure. It's cleaning it up before it goes in. Okay? And taking care of business there. Okay? That is what's happening. We're cleaning the rod up so it doesn't bring liquid, doesn't bring any dirt, any debris in, which then can tear the other seals and cause leaks. Okay? That's the biggest concern. Okay? Now, down here, you're like, Groom, is there rings on this piston? No. Good call, though. But there are seals and O-rings. Seals and O-rings on the piston. And different ones are different. You know what I'm saying? So like this particular one was designed to have 2 O-rings and a different seal. Okay? Maybe this one has 2 seals, one on going either direction. In fact, a lot of your 2-way acting cylinders will have 2 seals, one that more or less faces one way and one that more or less faces the other way, depending on which way the pressure is coming from. Okay? But that's not all. This is the one that sometimes people kind of freak out about. They're like, well, what's going to happen here? When I take this thing out, here's the piston. It is still attached to the rod. There's a big nut on this end out here. Nut. It's referred to as anyways, that nut out there on the end of the thing. We have to get it off. Now, here's your gland. Groom, how am I going to change the seals in the gland? Well, good. You're going to take the nut off, the piston will slide off, and then the gland will slide off, and then we can change them and then put them back on. But wait a minute. You're saying the rod goes through the piston. I am. Doesn't that mean there has to be seals inside the piston as well? And the answer is, of course, that's true. Okay? And so when we get to changing these, we're going to change the seals on the outside of the piston. There's going to be seals inside the piston, seals inside the gland, and seals on the outside of the gland as well. Typically an O-ring on the outside. Okay? So when we do this, that's something to be aware of. Okay? This nut is tighter than a hoo-hoo. Okay? So, a couple things. We're going to put a little bit of heat to it before we take them off. Always, because you will use Loctite on them. We will just use blue or orange. I'm not going to use red. Okay? It's not that, it can't come on. We can't have it coming off, don't get me wrong. But I'm not going to use red on it. Okay? It should be just fine with the blue. That said, I'm going to heat it up a little bit to help it come off, and then we're going to use an impact to buzz that guy off of there. Okay? Now, you think about that for a minute. How would you get this guy off of here? All right, how are you going to get that off of there? What are you going to do? Well, you're going to hold this piece here in a vise. That's what you're going to do. Never, ever, under any circumstances, do anything to the rod. It is made out of this very high, it's kind of a stainless steel stuff, but you cannot mar it. If you ding it up, it's going to tear the seals coming in and out. We cannot have that happen. Cannot have it happen. Okay? So when we look into there, like, hey, you've got to be careful. So instead of, like in the old days, what we would do is put this baby in a vise, squeeze the bejesus out of it, and then get out here on the end of it with a big old breaker bar and get after it. And to be honest, there's sometimes you still kind of have to do that depending on where you're at, what kind of tools you have. We have 3/4 inch drive and 1 inch drive sockets. I'm taking it off with the impact, okay? And it's going to be just fine. But I'm going to heat it up a little bit first just to be safe, okay? And we're going to go from that standpoint. Now, a couple other things that might come to mind. This is a cylinder then, technically, right? It is. What if there was some yuck in there, whether some rust, some corrosion or whatever? Can we fix that? And the answer is yes. We can ream it out just like we do with a regular piston in a car's engine. For the most part, we're not going to do a lot of that unless we run into one that's just awful, okay? If it's really bad and awful, you can try, but what you're going to find is if there's any pitting at all, that means this seal on the outside is not going to seal. And when you put pressure in here, it's going to leak around to the top side. Well, that kind of defeats the whole purpose. I need high pressure on one side, and I need low pressure on the other side for this to work. If I'm getting pressure on both sides, what's going to happen? That's problematic. Okay. Or, quite honestly, if what really would happen is I'm not building any pressure over here, or very little pressure, and this is all blowing by and going right back to the tank, yes? And so what happens to this ram? Well, it doesn't move. It just doesn't move. Hey, is that what happened on a couple of these cylinders? Yeah. What was happening on a cylinder, we were getting blow by. So when you tried to put that thing down, it actually fought itself. And if you might recall, the one on the left rear, when you tried to put it up, it got about halfway and then it started fighting itself again. That's because it was getting pressure on both sides, and it was like, I'm not going anywhere. Screw you. Okay? So kind of keep that in mind. Now, I'm going to pull up a video of a hydraulic cylinder. Or not a video, but a diagram. And so if I can show you some of the inner workings a little bit better than my particular. I want to open up, you dumb hippie. So this one doesn't show the gland. Oh, it's right there, stupid. Yes. I was trying to show when it actually had the pictures. Oh, for crying in the mud. One moment, please, while I find the picture. Don't waste your time. Okay, here's a couple of decent pictures here. So it's pretty good. It's a pretty good picture of the piston with its seals on the outside. You can see right there. There's your rod. It's chrome plated. Like I said, it's very important it stays beautiful. This right here, the bronze port, it's called a rod bearing, but really that is the gland. Okay, the difference is that this top is held in by rods that run the length of the cylinder on this one. You with me? And so instead of this end screwing off, like right across here where these bolts, 4 bolts hold that thing together. That's not the only kind. There are many other kinds here. Like this one right here is more the style that we're looking at here. You with me? So there it is. No, that's not the one I wanted. Gosh dang it, I just had it. All right, pause. Okay, this is a better picture right here. It's a better picture of the gland anyway. The piston has been cut away right here. You can see that. The piston comes over the top right here. That's where your nut screws on. This valve is if you overpressurize it, it can leak a little bit out. That's nothing that we're going to see. It's a little fancier than what we're going to have. But look at this gland right here. This internal gland. This piece on the outside, as you can see, screws in. You see that? It screws on into here. It's sealed by this O-ring. And then there's going to be seals right around the outside of the rod up here. Again, that's called the wiper, the rod wiper. And that cleans it off before it goes into the hole. Okay? Keeps all the yuck and nastiness out of there. Okay? So we'll be looking at this. This is primarily what ours we're going to be looking like as we get going. Okay? So just be aware of that as we move into these guys. Okay. Nice. The last thing I want to kind of just briefly touch on today is, well, Groom, isn't it true that all the excavators, the telehandler, and the skid steers, everything basically that's out there, including the roller, they're all hydraulic. Everything about those are hydraulics, okay? And so we will be looking at, in the coming days, I'm going to be bringing over one of the excavators and open it up. And you will see stacks upon stacks upon stacks of valves, okay? And so this stack feeds, maybe this one valve feeds this stack or whatever it happens to be. So we're going to be looking at that. We'll be getting into those a little bit more in depth, but we're also going to be looking at the motors, okay? So we have electric. Come on, try again, Jay. We're going to have hydraulic motors, okay? And this is attached to the track, right? That's the driver for the track. And so what ends up happening is, there's your motor. This is the sprocket for the tracks, okay? This guy here, whee, you're going to have a valve on this side, okay? You're going to have a valve on this side. Groom, you mean like the 2 sticks on the Bobcat for steering? That's exactly what I mean, sir. And so when I push forward, we're going to be pushing fluid through this guy in one direction, fluid through this guy in one direction, and then, of course, back to the tank. Of course, we still have our pump out here doing its thing, pump, right? And the pumps come to the valves, whee! And when I open it up, it's just going to circulate and do what? It's going to circulate. This is the tank down here, sorry. Okay, and it goes back to the pump, of course. But if I'm not moving anywhere, what happens to all this fluid that's being pumped? It immediately bypasses straight back to the tank, right? Obviously, that's what's happening. Okay, it just circulates through, doesn't do anything for us. As soon as I crack those valves open, it sends the power through this direction, and then it goes back to the tank. When it goes through, this is how I view it. It's not exactly this, but it's good enough for you to visualize. Inside the motor, what we're doing is we're taking fluid and we're pushing it, if you will, like against vanes like this. And so when the fluid comes through, it pushes it, and it causes this baby to spin. That's the way to think about it. We will get into some hydraulic motors later on. If you can visualize that, we're gooch. That's all I need you to see, okay, in your mind. You're like, Groom, what if I pull the other direction? Well, that's a good question. If I pull the other direction, well, you know what's going to happen. The fluid is going to flow the other way. And so what's going to happen is this. It's going to flow into the bottom of the motor, and then it's going to come out at the top and go back to the tank. Now, that's a poor rendering. We'll get under there and look at them and see how it all works out later on. But that's the idea. What is that going to do? It's going to spin my motor the other direction. Okay? So, on the excavator, if you count them, there's one to run. There's one. Let's think about that for a second. So, there's the thumb. There's stick. There's bucket. There's boom. Okay? Then there's the blade, okay? And then there's also, when you swing the boom, right? Is it one or two? I can't remember. There's one or two cylinders that swing the boom side to side. So if you want to just take your boom and stick it off to the side 60 degrees. And then there's also swing the house, right? So swing the house either direction. That is a hydraulic motor that swings the house around. You're sitting on top of a motor, basically. Whee! And then you got the two motors for driving. So for your excavator, there's got to be one, two, because you have to have a circuit for each side. 3, 4, 5, 6, 7, 8, 9. At least 9 hydraulic circuits in an excavator. And you're like, Groom, which one gets the more power? In other words, does one of them get priority? And driving typically gets more priority. You'll also notice you can curl more than you can stick, yes? And you can boom sometimes more than you can stick. And so some of them have, and it depends on each one of them, how they are rated from the factory, right? So they just, this, in our particular one, let's say the Takaguchi, we're going to have more power. Stick's going to override bucket or whatever, right? You would never do that. But let's say that would have it. So if there's a choice of, well, one of them has to go without, because again, we're moving a lot of fluid. If I'm cracking 2 cylinders open, I'm trying to move several things at a time, something's got to give. Okay, something's got to go hungry, something's got to not work right. Okay? Ditto on the Bobcat. Today I was scooping some dirt with the Bobcat. I hammered down, I was really digging hard, and as I was coming into it, the tracks really started spinning. The motor was going wee, and I'm trying to lift up, and the buckets didn't want to lift very good. Okay? So I had to kind of back off the motors to get the lift to come up, because that thing prioritizes the motors that run the thing versus the hydraulics to lift things. Okay? So just be aware of that. The thumb is always going to be at the tail end of everything. So, if you're doing a bunch of other stuff, then you try to move the thumb would not react properly. Okay? That's just typical in these situations. Okay? We'll be looking at these in depth next week and a little bit more. I wanted this to kind of have us ease into the lesson when we go to tear it apart. Now, for the remaining time, I'm going to have, I think, a quick, actually, no, it's probably enough for today. All right. Yeah, perfect. All right. I think that's enough. Good night. Take notes.